So this is called as tokens. Whatever the word you are giving, right? Whatever the word, phrase, sentences you are giving, it is just segmented as a tokens. That is why you have the limitations in ChatGPT or Claude or whatever it is. Per day, a free user will get this many tokens. Okay. So we'll come back to the other questions in your mind. You can just open up your mind now. Okay. So this tokenization, whatever the information, it will just segment it into words, meaningful words. Each and every word is called as token. Even a punctuation is also one token. We'll see how it has been taken into a one token or two tokens or multiple tokens. The next thing, part of speech tagging, POS, assigning word types to tokens like verb or noun. Whatever the word you are typing, it just segmented the token. After tokenization, it will be segregating into whether it is a verb or nouns. Okay, it is trying to identify what is this word. Is it a verb or noun? That is called as part of speech tagging. So next is dependency parsing, assigning syntactic dependency labels describing the relations between individual tokens like subject or object. This is a dependency parsing. We'll see the example. Okay. And then lemmatization, assigning the base forms of words. For example, the lemma or lemmatization. Lemma is, in the sense, it is a root word. I think I already discussed about this, one of the conversations. Whatever you are telling in medical terms, right? There will be a low-level medical terms and up to high-level medical terms. The high level is a root cause, a root word. Like if you're saying headache, it is directly connected with your nervous system, CNS, right? Central nervous systems or any other, the CNS form, right? If you are telling heart attack is a low level term. The root word, the root thing is, it's a cardiology. The same way, if you are typing some word like was, right? Was is a past tense of be. And also is. Is the present tense for be. And the lemma of rats, it's a plural. Rats is a plural. So the lemma of rats is a rat. So likewise, whatever the word you are typing, it is getting connected with the root word. That is lemmatization of the word. And then sentence boundary detection, finding and segmenting individual sentences. Named entity recognition, labeling named real-world objects like persons, companies, or locations. Maybe if you are just, go and search for the word Sachin. Sachin is always refers to a celebrity in terms of natural language processing. If I search, I will show you. Sachin. It will directly connected with Sachin Tendulkar because he is a celebrity and he is very famous. And internet, the natural language processing of this information is directly connected with this guy, right? And also Amitabh Bachchan is directly, it just directly connected with, that is why you are getting this. The other information, like, we'll say search engine optimization, whatever it is, blah, 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 other kind of a terminology, that is a secondary point of view. But the first point of view, it is directly connected with one thing. And I will show you one more thing. If I say apple, apple is directly connected, not connected with fruit. It is connected with an entity. It is connected with an organization. Okay. This is how the named entity recognition will work. Labeling named real world objects like persons or companies or locations. This is called as named entity recognition. Apple, from the natural language processing point of view, Apple is meant only for the company, not as a fruit. If you want to search as a fruit, it should be apple fruit. You have to type it. There is no other way. Do you understand? I think, what Senthil was asking the question. Slowly, we
Yeah.
are listening to.
So you just type Orange. Orange is also a very big company.
Yes.
Um, okay, let me.
Yeah, here. Okay.
Orange. Okay. Okay, show the fruit as well. Okay. Orange.
Orange cap in IPL.
Depends on
Orange.
it depends on how the search is being done. For example,
Hmm.
on Google, majority, if when you take Sachin as a name or Apple as a name,
Hmm.
majority of the people use Apple as a name to search for Apple company products. Same is the case with Sachin. Like when they are typing about Sachin in the Google, that means they want to know more about Sachin Tendulkar. Same case, Senthil, when you type orange, whatever the majority number of search hits are there, uh, that will come into your top list. And there is a concept of SEO. That concept, like whichever company is paying more to Google, their name will pop up first. So if orange is not searched majorly by people for a company, then that will not come.
Optimization. You mean? Okay.
So the next one is entity linking. Disambiguating textual entities to unique identifiers in a knowledge base. So that is where we have seen about the knowledge base in previous classes. In this entity linking knowledge base, they have all the text informations. It is getting assembled like a dictionary, and we are just if it is able to identify these things, then it will always be a unique. If it is not, then it will create some kind of it will give you some other information. That is why it is like disambiguating textual entities to unique identifiers. Similarity, comparing words, text spans, and documents, and how similar they are to each other. So similarity search also will be done during this process. Okay. Text classification, assigning categories or labels to a whole document or parts of a document. So if you are just giving, nowadays, it is very really possible in ChatGPT and also, other large language models. You can attach a document and it will just, classify what kind of a document it is or group it into categories, or it will just label the entire document or, the part of the document it will do. The basic concept is it starts from this text classification. And then rule-based matching, finding sequences of tokens based on their texts and linguistic annotations and similar to regular expressions. And then training, updating and improving a statistical model's predictions and serialization. Okay. So we'll just see with the example first and then we'll see. Yeah. What I'm going to do, I'm just running this piece of code. Here it is a linguistic annotations. Actually, in NLP, Apple is looking at buying UK startup for 1 billion. So this is a text we are going to analyze. How this search or this has been understood by this library in the NLP processing. So we are importing spaCy library, and then we are trying to load this, the N core web SM. What does that mean? It is English core. It's a web dictionary. Okay. From this spaCy library, we are trying to load this dictionary first of all. And then we are creating a document as a DOC. As you know, we are taking it the NLP from this information. We are assigning this, creating this variable NLP. In that NLP, we are asking Apple is looking at buying UK startup for $1 billion. And then we are trying to analyze what are all the tokens are inside this document through this NLP processing. And we are trying to print token.text, token.pos, and token.dep. POS is nothing but part of speech, and token.text and how this text is getting converted, right? And how this DEP, token.dep is getting descriptor. Okay. So how the spaCy tokens taken into objects. Okay. Just look at this information. Apple, the word apple, it's a preposition. Okay, it's a noun, it's a name, right? And then is, it's a auxiliary verb. And looking is the root of, lemmatization for looking is root. Okay, and then at it's nothing but adjective. Buying, it's a verb, buy. U dot K dot, it's a preposition. It's a country name. And startup, it is a noun. For, adjective. Dollar, symbol. One, numeric. Billion, again, it's a numeric. Okay. And this is how at the back end of each search or each document or each phrase, it will be tokenized inside this NLP. Okay. And this is the basic process in every search. Okay. So spaCy provides a variety of linguistic annotations to give you insights into a text grammatical structure. This includes word types like the part of speech and how the words are related to each other. For example, if you are analyzing text, it makes a huge difference whether a noun is the subject of a sentence or the object, or whether Google is used as a verb or refers to the website or company in a specific context. Once you have, this is the trained pipeline where you can just click and you can just get the GitHub link, I guess. Just click that. You can just go to spaCy.io usage.
What is IO, Sini?
Input output.
.io.
Input output.
Okay. Is that any address specific domain in that? Input
Yeah.
output.
Yeah.
IO.
I can start my deepmindsystems.io, deepmindsystems.ai. These are all the
Okay. I see in most of the AI related companies they have the IO dot
yeah.
IO. So is there any specific related to the we can easily identify that these companies are dealing with the AI stuff?
Exactly. Easy identification of they are only on specific AI companies or like that. So it is just if you are giving input, you are getting output. So it is actual information from AI. So that is what they are doing. I mean, it's comparatively .com website, it is expensive, and also .ai, that is also available. Okay. So this. Okay, this will return a language object containing all components and data needed to process text. So we usually call it an NLP. It's calling the NLP object on a string of text will return processed as document. So even though a document is processed, split into individual words and annotated, it's annotation, right? In your annotation, the same kind of a meaning. It still holds all information of the original text, like white space characters. You can always get the offset of a token into original string or reconstruct the original by joining the tokens and their trailing white space. So this way, you will never lose any information when processing text with spaCy. There are so many applications that are available using spaCy. We can just, go and search for it. And this is how it has been tokenized. Okay, again, I will just run this code. This is a different block, and this is a different block. And I'm just asking only the tokens, how it is being read. Apple is one token, ETH is one token, looking at buying everything. You dot K dot is one token. See this, dollar is one token, one is one token. Obviously, billion is also one token. Just to see, look at this table. This is how it has been tokenized.
Every word is broken.
Yes. But u dot k dot, it's, if you broken, it is trying to identify from this English core web SM. This a small dictionary, the English core dictionary of spaCy. Not only spaCy, even NLTK, Natural Language Toolkit, is also having the same similar English core dictionary in their NLP. So wherever you go, they'll be using this core dictionary. In that core dictionary, this is how it has been tokenized. If you are mentioning any country, it will take it as a one token. It won't be taken it as a two tokens. It will be one. Okay. And this is the process. If it is, let's go to New York, N dot Y dot exclamation, right? Just see each and every, how it has been transforming in NLP. Prefix, exception, suffix. These are all suffix. Let's see the green one and also the blue one and also the gray one. Okay, this is how it is getting processed. First, it is trying to understand what is let's, right? And then N dot Y dot, it is, a separate thing. And also the double quotes, it's a separate entity, separate tokens. Let, it's a separate token. Apostrophe yes is a separate token. Go to, and New York is the whole thing, but it is N dot Y, it's a separate token, and exclamation, it's a separate token. And this is how it has been tokenized. And you can find the tokenization tools, the common tools in NLP over, and also with respect to spaCy, you can find it over here. And then it is a part of speech tags and how it is, being done. I think Sendil, you wanted to go now? You can stop over here, because if you start, it will never end.
Oh, okay.
It will go on.
Yep.
Next.
Shall we look at the program? I think that execution is completed. Then we can.
Okay.
Close.
Okay. Yeah.
So will I stop over here? If that, execution, okay, then let's just restart running that program and getting to find out the single image at last portion of the code. And then we'll continue the spaCy tomorrow as well.
Yeah.
Okay.
The part of speech will continue tomorrow, Sini.
Yeah.